This is Team Castronauts, and I am Kwa. I am the team leader for this hackathon, and this is our video presentation for our system. So we call it the Compliance Flow. Compliance Flow. So it is a multi-agent financial compliance pipeline using Google ADK. Our project falls under the agent for business category, and we are solving real enterprise problem by automating anti-money laundering (AML) and know your customer (KYC) transaction compliance review, which is something that almost every bank in the world is legally required to do. So here's the problem. We are trying to solve a real $200 billion enterprise problem. Banks are legally required to review every transaction. Every financial institution must review transactions against multiple regulatory frameworks like anti-money laundering, know your customer, sanction screening, and legal compliance. Today, this is still a manual revision process. This involves like 3 or 4 human teams passing documents back and forth, a policy team to check the rule, a risk team to score the threat level, a legal team to review against frameworks like Bank Secrecy Acts like BSA or OFAC sanctions, FATF, etc. And then a senior officer who makes the final call to proceed with that transaction or not. So this manual review is very slow, it's expensive, multiple team hand-ups, very error prone due to human error, and it can be very biased and to a specific company with bribery perhaps can be involved, and it is very expensive. And according to McKinsey study, banks globally invested approximately $214 billion on financial crime compliance in 2020, and in the US alone, a 2024 LexisNexis survey found that AML compliance costs exceed $60 billion per year, and global AML system spending is projected to reach $51.7 billion by 2028. So when compliance fails, the penalties are devastating. Between the year 2000 and 2024, regulators worldwide imposed a total of $45.7 billion in AML and sanctions fines. HSBC paid $1.9 billion in 2012 for laundering money for Mexican drug cartels, and Deutsche Bank paid $629 million in 2017 for Russian mirror trading schemes, and Goldman Sachs paid $2.9 billion in 2020 for 1MDB violations. And in 2024, TD Bank was hit with a $1.3 billion fine, which is the largest fine in the US Treasury history. So we asked the question that what if each of those human team was an AI agent and they could coordinate automatically? So that is the stance of our project. So let's talk about the system architecture first. So for the input, there are 3 ways to submit a transaction for review. So first, we have the web dashboard using fast API and classmorphic UI, where a compliance officer can type in a transaction description or upload a CSV batch transactions. And second, we can directly through a CSV, so we can integrate this system into any pre-existing system that banks have, and they just need to pass a CSV into the system. There's no need for any dashboard. And the third way is manual prompting via ADK Playground. So once the transaction enters the system, it hits our Google ADK sequential agent pipeline. So it is the core of our project. 4 specialized agents who are running in sequence. 4 of them are policy agent, risk agent, and legal agent, and decision agent. So agent number 1, the policy agent. It checks the transaction against AML rules, KYC requirements, sanction lists, and transaction monitoring patterns. It has access to 2 custom tools, which is a jurisdiction checker that flags FATF high-risk countries, and a sanction list checker that queries OFAC entries. It produces a structure assessment which is clear, flag, or blocked into the policy assessment. Now, agent number 2 is risk agent. So it will receive the policy agent's finding plus the original transaction. It scores risk from low to critical based on amount, counterparty profile, jurisdiction, and anomaly patterns. It also has access to the jurisdiction check tool too. So agent, and it outputs to risk assessment. And agent number 3 is the legal agent. It receives everything from policy and risk, and then reviews against legal frameworks like PSA, OFAC sanctions, FATF recommendations. It determines whether regulatory filings like SARs or CTRs are required, and whether human legal counsel is needed. It has access to the sanction list tool and output to legal assessment. The final one is the decision agent. This is the final synthesizer. It receives all 3 upstream assessments and applies decision logic to produce one of 4 outcomes. It's either auto-approve or enhance review or escalate or decline. Auto-approve for clean transaction, enhance review for medium concern, and escalate to human for serious issues, decline for clear violations. So the key architecture point is that each agent writes its output to ADK output key, which is the assessment that you are seeing on the screen. The policy writes to policy assessment, risk writes to risk assessment, legal writes to legal assessment, decision writes to final verdict. This means each downstream agent automatically has the access to all the upstream findings through ADK's built-in state management. No manual message passing, no manual ping mentions, no stuck messages. ADK will handle the coordination perfectly. And finally, we have the output layer, which will show the dashboard display. I would do a demo later on and resolve to output the resolve.csv for audit trail export. So we'll talk a little bit more about the Google ADK features that we use. So first one is the sequential agent. This is the ADK's built-in orchestrator for running agents in a predefined order. We define 4 agents and pass them as sub-agents to a sequential agent called compliance pipeline, and ADK handles the execution orders, state passing, and error handling automatically. Second is the output key state management. Each agent declares an output key, and when the policy agent finishes, its full assessment gets stored under policy assessment in the session state. The risk agent's instruction template includes policy assessment as a variable. ADK will automatically inject the previous agent's output. This is how context flows through the pipeline without us writing any coordination code. Third one is the custom tools. We define 2 Python functions. First one is check high risk jurisdiction and the other one is check sanction list, and attach them as tools to the relevant agents. The policy agent can call check sanction list during its analysis. The risk agent can call check high risk jurisdiction to verify FATF status. And these are real function calls, not just prompt-based reasoning. The model decides when to call them based on the transaction contents. Fourth one is the in-memory runner for evaluation. We built an evaluation suite in run/evil.py that uses ADK's in-memory runner to test 3 representative cases: a low-risk B2B transfer, a high-risk cash transfer to a gray-listed jurisdiction, and a direct OFAC sanctions match. The eval checks whether the pipeline's verdict matches the expected outcome. Fifth is the agent skill. Under the .agent/skill directory, we created skills.md files for each agent roles: policy agent, risk agent, legal agent, decision agent. These are persistent domain knowledge reference that anti-gravity uses when working under the project, and they encode the regulatory frameworks, output formats, and decision logic for each role. So yeah, we mainly use anti-gravity for development, and yeah, as this is a vibe coding hackathon, so we try to vibe code as much as possible, still with previous setup that we had from Fast API, Fast API and REST API. So we use anti-gravity as our primary development environment. So the workflow was that we install the agent's CLI toolchains and loaded the APK skills into anti-gravity. Then we describe what we wanted in natural language and let anti-gravity generate the initial agent definition, tool function, and pipeline structure, and then we develop them from there. We iterated, right? We then iterated, like refining prompts, adding evaluation suite, building the Fast API dashboard. Each step was a conversation with the anti-gravity. The agent skill we created also served as context for anti-gravity, so that when we asked it to modify the legal agent, it reads the legal agent skill.md and understands the BSA, OFAC, ATF framework that the agent operates under. This keeps the AI generated code domain accurate. So this is vibe coding in practice, and we acted as architects, and anti-gravity did the typing. And now I want to do a UI UX walkthrough for you. So I will off the screen for now. Okay, so I have already started running the dashboard right here. So here is the screen. So we have right here is the total amount of transaction currently inputting into the system. So this is the pending for review, awaiting for review. This is processing, currently being processed, and these are the completed transaction, and these are got the error or timeout. So we can refresh or clear the queue for fresh starting on the system. So right here we can see I can use this to show only the transaction that each officer inputted. Like if I put officer Khoa here, I can only see that the transaction that officer Khoa inputted, which is me. And if I just simply put director Khai, then you can only see Khai's input. And this is submitted by whom? It's officer Khoa. So right here in the transaction description, as I mentioned earlier, I can directly type it like any transaction into here, like just for an example, $1 million investment into Sky Sport F1, etc., something like that. So it's just for demo. And right here, assign to users, so we can upload as patches of CSV to drag here and put the CSV input into it. And down here we have a verdict breakdown to see the overall progress of how many percentage of completed transaction on the total transaction. So we can see the distribution of out of the outputs, either out of brew, enhance review, escalate order, declines, etc. So right here we have a monitoring screen, all pending, processing, complete. It will be easier to understand when you see it. So I will input this. So we have transaction Khoa, transaction V, Khai. So these are from three different persons. The format is just very simple. The name of the owner of the transactions, the input transaction, and the description of the transaction. Very simply, just 2 columns. There's no need for any indexes, something like that. So I will put this on first for officer Khoa, and you can see it's here, user officer Khoa. So I'm putting officer Khoa here. You can see all of them like right here. But if I change it to Ravi, you cannot see it. So yeah, it's back here. So yeah, 17 total transaction. Live domestic wire package. Okay, auto approve. You can see here processing completed 1, pending 15 are pending. So yeah, like that. Escalate to human. Yes. Yeah, the sticker down here. Just like that, very simple, and it works very well, especially with Google ADK and auto coordinate. It's very perfect. You can see the time here as well. So pending is run here, processing you can see right here, ID from 5 to 17, processing completed, like that. Yeah, the pipeline is very nice. This one failed for some reason. Yeah, there is instances that the pipelines fail. It can be. So yeah, I think it's kind of time now, I guess. So we'll see. It's approved. So let's try. Okay, decline. Yeah, very nice. So yeah, there are instances that calling of the agents got error, and either it didn't get the. Yep, there's a lot of there are nuances I cannot tell yet. This is one of the future works that we need debug, more debuggings on these. So we'll see, and yeah, see the output. Okay, we have refresh and clear queue. So refresh, you can see it changing the queue, new update, and I can very simply clear the queue. So yeah, right now I want to test. I want to add more. So right now we're at the guide. Yeah, right here. So we'll see. So uploaded, and refreshed. I'm making some error with it. Yeah, there you go. You can see the rectifier here. Oh yeah, I was putting the officer class, so all users should be like this. Yep, very nice. Very nicely done here. So 2 failed already. Still need to fix on that. And I want to clear the queue. Okay, clear the queue. Okay. Re-upload from. Re-upload from guy. Here. Let's see. 16 transaction. There are still a lot of fixes that we might need, but this is very good already. So yeah, it is like that. That's the pipeline. It's working very quite nicely, and still there are a lot of improvement that I want to talk about. There's the logs of the frontier. You can see the logs of the pipeline for each event. Decline. So yeah, I just kind of exceeded my quota. So yeah, that's the error only. Very simple at that. Okay, so what we'll talk about right now is the future development of the project. Still, even though it is working quite nicely already, there's still a lot of more room for improvement. First is parallel agent execution. Right now, the 4 agents are working in a sequential manners, policy and risk and legal and decision. Risk and legal doesn't depend on each other. They can run simultaneously using ADK's parallel agent capabilities, cutting the processing time nearly in half. I haven't developed this yet, so it is a future development. And secondly, is the real regulatory database integration. Jurisdiction and sanction tools use hard-coded lists right now and in production. These would query OFAC and SDN lists and FATF country assessment via API. And third is probably cloud deployment. ADK supports deployment to Google Cloud via agent runtime. So the dashboard would run on Cloud Run, and the pipeline would process transaction at scale with full observability. So yeah, that's it for our project. Thank you for all your time. Yeah. So this is the ComplianceFlow automated compliance review powered by Google, ADK, and Gemini. Thank you so much for spending your time, and thank you and goodbye.